Go.
Hello!
Hello, Mr. Aaron, Mr. Ryan. How are you today?
Good.
Okay. So
Yeah.
today we talk about the maze. What is maze?
It's like you're in the maze and you need to go to the end and there's some dead end. No. It's like an obstacle.
Obstacle. Yes, obstacles.
Okay, it's the one that you need to go to the exit.
To the exits. Yes. Okay. So look.
Need to be hard, not easy.
Okay. So given look. Let's just write this.
How can we draw a maze?
Good one. Okay.
Hey, the zeros are the path you can go, and the ones are the walls.
Okay.
That's gonna be super easy.
Yeah, well done. So zeros are the empty space you can walk. One, the wall. Okay, one wall. And where's the entrance? Entrance is the top left. Yeah.
Yeah.
Entrance, yeah? And where's the exit? Yeah. The bottom right. Exit. So here, look, you can go here, or I can go here, go here, go here, go here, go here, go. Yeah? Okay? So what's the shortest distance? 1, 2, 3, 4, 5, 6, 7, 8. Okay? So 8 steps. The shortest distance, 8 steps.
That's what
However,
we're trying to find out.
However, if I block it here, I put it here.
There's no way.
There's no way. Then you need to tell me it's -1. Right? Does it make sense? If I block it, there's no path. Yeah? If the exit is 1, you always return -1. Or the entrance is 1, you return -1 as well. Right? Because the entrance and the exit are blocked. Okay? Okay, so is it clear? Is it clear? This problem, is it clear?
Yeah.
Yeah? Yeah? How do we solve this?
Okay. With a matrix.
Metric, okay, so one of all is shortest distance, okay? We want the shortest distance. And it's you can expand it as like a graph search problem, right? How do you search a graph with the shortest distance?
Wait. So first, if the exit book and whatever you say all the day, and if there's that's what.
Sorry?
And you turn -1.
Yeah.
Yeah, and then.
I'll give you a hint, okay? So at this point, at any point, I can go to 4 directions, right?
Oh yeah, I know. You start from it. You can come from here and here.
So
Still here.
so look if this entrance, I can go to the 4 directions, right? Or 2 directions, yeah? Possibly 4, right? If it is here, it's
The
possible.
maximum.
Okay, so look, you can expand it as the next 4 nodes. So what does it look like? And then look here, you can have another 4 directions until we reach the end. What does it look like?
Enemy tree.
Yeah, but how do we travel this? Look, and here you have another 4, maybe, or maybe 3. And here you have another 4. And here you have another 4. What is it? And then go to the next level.
The binary tree is
then-
actually like going in quarters. Well, it's like going in quarters.
So what does it look like?
Fibonacci.
No, so what does it look like? If I visit this one, and then the
An
next
alien.
step, and then the next step, and the next step.
An alien.
So look, this is step
Bottom
1.
up. Top down.
No, this is step 1, first step, and then let's do
Enemy tree.
2 steps. What's this search? Come on, what kind of
Binary search.
Sorry?
Binary search.
No.
Binary search tree. Breakfast search.
Yeah, breakfast search. Look, because look here, as I give you a hint, you will visit the next step and the next step. Okay, well, enough. And whenever you visit, look, so breakfast search gives us the guarantee of the shortest distance, right? Guarantees the shortest distance. Am I right? Yeah. Because look, I visit the step 1, visit the step 2. But the first time, if I'm at exit, I can guarantee it's the shortest. Am I right? Yeah, does it make sense? Okay. So let's breadth search. So we can treat this as a graph, okay?
This
Okay.
was right.
Yeah. Okay. Let's do this.
Example 1 and example 2.
Let's do this. Let's do this. I give you already the hint. Look, shortest distance graph, and can we solve this using the depth search?
Yeah.
Yes, maybe, but breadth search is ideal here because depth search you always go to the right. You always go as deep as you want, but you don't know if that load leads to the exit, right? You might spending time trying impossible path. Am I right?
Yeah.
Does it make sense, Eric? Yeah. Can we do it? Can we do it? Let's do it.
Oh yeah.
Define
This looks easy.
escape maze.
Escape.
Maze. And we give it a metric. Let's just do it M, okay? Okay, metric.
Maze.
And what are we missing?
Cartoon.
Okay, then rows. We want to find out the rows is length of metric, right? And columns is length of the first metric, so it's M0, right? Right? Does it make sense? Okay, look. Okay, look. If rows equals 0 or columns equals 0, returns -1. If the maze is empty, I just return, okay? I'm not going to write here, but it's good to check if rows equals 0 or column equals 0. What does it mean? It means the maze is empty. Then we return -1, okay? Yeah. And look, if maze 0, 0, the first top element is 1.
Return -2 or -3.
Or n minus
Or
1
0.
minus 1. Eric, can you tell me what does it mean? N minus 1 minus 1 equals 1. What should we return? Return what?
Return false. -1.
Minus 1 or false. Yeah, you return minus. Look, if the
Yeah,
top... Eric, come
Okay.
on.
P. 25 pounds.
Okay, so look, if M0, 0, so which element is this?
M00.
Yeah, and n minus 1 minus 1, which element is this?
M -1 minus any M -1.
Yeah, -1, the last element, yeah. So if either of them is 1, it means the entry or the exit is blocked, then we return -1. Does it make sense? Yeah?
Hulk
Okay.
can do it. Hulk can smash it.
Okay.
Hulk smash.
What kind of data structure we need to use to implement the breakfast?
Q.
What's Q? What's Q? Okay.
Hi.
Come on, be quiet. What? Remember what happened yesterday?
Yeah.
Okay. What in Python? What function are we using? What kind of class are we using to define the Q?
Class solution.
No, define the Q. What Q is it?
Q. DQ.
DQ. What's DQ?
Double-ended Q.
DQ, yeah, double-ended.
Huh?
What does it mean, double-ended?
I mean, it's double-ended.
You can push and pop in the both
Exactly.
sides. Okay.
Me.
Okay. Now look. So first of all, we need to push the first element into the queue, right? So which is the look, Eric. Q equals DQ. Okay. And I'll push the 0, 0, the first coordinate. Yeah. We are here, right? Entry, right? And then we need one step, right? So
Yeah.
there's a tuple, yeah, 0, 0, 1, and then bracket, yeah, right?
Yeah.
So we put the first step, okay? Ryan, can you sit there, please? Now, wire Q,
Eric.
okay, wire Q.
He's not sitting.
When there's element in the queue,
I don't have
right?
a chair.
When there's element in the queue, okay? What happened? What do we do?
Because you're sitting on it.
No, I'll give you. When there's element in the queue, what should we do? We take it.
Yeah, we pop it.
We pop it, yeah. So,
Yeah.
so look now,
Everyone
we
knows.
are at this position R, C, and the current distance, okay? Current distance equals Q dot what? Q dot what? Dot what? We want to take one element. Pop what? Because it's pop left. Because it's DQ, it's pop left. Okay? Can we focus? Go on the drawing, okay? Look. Look here. Look, if R equals rows minus 1, right? And C equals columns minus 1. What does it mean? What does it mean? If R and C is this one, what does it mean?
It means it's weak entrance.
We are entering, so what should we return?
Exit, I mean.
We are at exit, so we should
Return the
which one? Which
return
value?
true.
Which value? We are the distance. We want to find the steps. The distance. Which value?
D.
D. Yes, we're done.
Booyah.
We're done.
Okay.
Okay. That's it.
With the
Then-
objective.
Then we are at RC, right? So there are 4 possible directions, right? We are at current RC. We are here. So where can we move? Eric, we are here. So where can we move? Next one. We are here.
Hair.
Yes. And then this and this, yeah. But we need to check if it's one, yeah. There are 4 directions. You can go 4 directions, right?
Yeah. But if you want to do that, you need Hulk smash. Hulk smash.
No, we know he's gonna smack. Okay. Look. 4. D. Like now we look. DR, DC in 4 directions. Now we can do this. Look. 0, 1. This is the offset. Yeah. 0, 1 means that right. 1, 0 is what? If 0, 1 is right, 1, 0 is what?
Left.
No. 0, 1 is right. 0 minus 1 is left. And
How come?
1, 0 is what? 1, 0. Down.
The bottom.
Okay, and then up is what?
0.
Up. Minus 1, 0, right? Because look, because it's rows, alright? This is rows, this is columns, yeah? Alright?
Mm-hmm.
Look, 0, 1 means what? Rows plus 0, columns plus 1. So it's on the right, right? Yeah? Does it make sense? Okay. Look, and then NR equals R plus DR. And can you tell me NC equals what?
C.
C plus
D.
DC. Okay.
That's what I was about.
Okay. If 0 smaller than equals NR smaller than rows, right? And what? And what? Rows, the new rows is between the size of between 0 and rows, and then
Columns.
and then NC 0 smaller than NC smaller than columns, right?
Yeah.
Also N and what? And M and R and C is not the wall. So what should I put here? If it the next picture is not a wall, so what should I put here?
We shall.
M is NR and C is not equals to what?
Is not equals to N.
So I'm here at NR. I'm at current position RC, and the next position is NR and C. Try these 4 directions, and if the next direction is still in this maze, not outside the maze, and also it's not a wall. So what's the wall picture here?
Huh?
What's the wall picture?
Wall picture. Somewhere.
Come on! Look, I'm
There.
here. Can I move here? No, right?
Nope.
No, so I need to check NR and C not equals what? Wall. What's wall?
What? Minus
1.
1.
1, just 1. Come on. If it's not a wall, then what should I do? I should push it to a pen, yeah? A pen, right? Put it into the queue, remember? Remember? The breakfast search, you remember? Do you still remember the breakfast search? Yeah? Take one element, push all its kids to the queue, right? Right? So what should I append? What should I append?
Append.
Append what?
Right.
Append what? 3 elements. What's 3 elements?
C. D.
What's R? No. What's the next picture?
D.
N, R, N, C.
C.
And what?
D.
D what?
And D. And D.
D is the distance. Current distance is D. So what's the next distance?
And D.
There's no ND. What's the next distance?
And M.
Now I'm here, D. I walk a step. What's the D? I walk one step.
D at 1.
Yeah, D plus 1. Come on.
Yeah.
Write down. Okay.
D.
And then return. If I here, return what? Return what? Return what? Outside, if the buffer search finish, we still can't find the exit. Here.
Return answer.
Return minus 1. That's not answer. Come on.
There's no.
There's one problem. This is the basic of the breakfast search, but there's one tiny problem. It's that look, if I'm here, right? Yeah. If I'm here, I push it next step here, right? But when I'm next step here, I also push it back the next step, right? So does it make sense? So if I keep walking here, left, right, and when I do this search, I expand and go to the left. I go back to the original place. Does it make sense?
Yeah.
Do you understand? So how can we solve this problem? Because breakfast search.
Breakfast search, thank you.
Breakfast search. Look, Eric. Look. So I'm at this position. My next step include moving to one step to the left, right? But now when I'm visiting this step, popping it from the queue, and my next step including the right, I pop it to the right. So what does it happen? I'll keep moving here. You will never find the exit. Am I right? Yeah? Does it make sense? Do you understand the problem? Do you understand the problem?
Yeah.
Okay, so how can we solve this? We're using
Hulk smash.
no.
Q.
No, we're using some kind of text structure. What?
Stat.
No. Come on, we want to. Notebook. Yes, the notebook is the data structure to see, to remember something, right? So here, look, we use the notebook scene. Okay, we've seen this before. Scene equals set, right? Alright, yeah. And then here, what should we put here, Eric? Here, right? Here. I added before this. What did I add, Eric? If R C in scene, right? We have seen this before, right? Yeah, Eric. We have seen this location before. We continue. So we don't want to continue the rest. We want to continue to the next iteration. And otherwise, what do we do? Scene dot add what? Add what? Can you tell me? So if R scene is already seen, we have visited RC position. We need to continue. Otherwise, what should we do? We should put it in
Notebook.
So scene dot add what?
Pop. No, add append.
Add what? Add what?
RC.
We are done. Does it make sense?
Yeah.
What's the time complexity?
N.
What's n?
The number is in the notebook. The number of. The node in the matrix. No, the number of thingies in the maze.
The numbers in the maze, the pixels in the maze. Okay, what's the space complexity?
N.
Why?
Because it's
Sorry, slow down. Sorry. What?
Not the Q.
Sorry?
Q.
Q. And
DQ.
and set.
Set.
Q and set. Am I right?
Yeah. Yeah.
Okay, let me see if there's anything missing here.
Now today we get now time for a break time. People.
Okay, wait. Not yet. Let me erase one of these.
Oh no. I sure you need to see it. Because it's moving.
Please, not shaking every time. Can you not shake this, okay, please?
Oh yeah.
Okay. Close your eyes. Okay, just that. Okay, and maybe a little bit here. Okay.
Yep, and now we got it.
Can you help Gaga? Eric, Ryan.
I think it's M. Yeah.
Yeah? Okay, and what? So if the next picture is not a wall, if the next picture is not a wall, And what? Bracket, curly, square bracket, not yeah.
And
What? You can use mine if you, this is broken.
N R N C D plus 1.
No, yeah. N R, yes.
N R N C
No, bracket. You need to look at,
N
how do you
R
reference this?
N C and D plus 1.
You write it, come on.
D N C.
How do you reference the pixel?
N C. And then D plus 1.
What's D plus 1?
The space. The
No. What are you
Even.
doing? You want to check NRNC if it's not
The distance.
if
Plus
it's not equals 1, right here, right?
N R N C. And then
What did I say? Here. What? Not equals 1.
not equals
1 column. And then what should we do? We should push it, append it to the queue. If the next pixel is 0, basically we're saying that if the next pixel is 0, so we find a new step. So we need to push it in the queue, right?
yeah. Say
What?
M
Q, what's Q? Q dot append, come on, what you doing?
Q
Dot
dot pen.
append what? Append what?
Is it this?
Yeah, append, but you need to append like that. Look, append these things, three elements. 3 elements, yeah, and bracket.
R C
Yeah.
and D. Like this.
Yeah, no, another bracket, two brackets.
R
Parentheses,
C
yes.
and D.
That's a tuple, right? Tuple, yeah.
And then
What?
N O
Yeah. What are we pushing? Yeah. And what? Come on.
N C
Yeah.
It's
come
like
on.
21 minutes, 22.
And what? D what?
plus 1.
Yeah. Can you explain why is D plus 1?
Because that's the next
It's
step of
22
D.
Okay.
minutes.
Put another bracket.
Bye.
Can you not shake? That's it. That's it.
Bye.
You can do some beatboxing.
Bye.
Can you do some beatboxing? Okay, that's it.
Bye-bye.